Hello, hello, hello. Ciao, Matteo. Welcome back.
Ciao, Luca. Welcome back, everybody. And we are in for another session on a topic that is very dear to me, Luca.
Oh, I thought you were saying we are live.
We are
Yeah.
live. Come on. Yes. Of course.
Today we are talking about. We were just talking about some other Italian person, kind of like opening up Italian secrets, and today I feel a little bit like him. We are debunking a myth, the GraphQL myth.
Luca, this is fun. It's a fun. It's a huge fun topic, to be honest.
Yeah.
We are talking about GraphQL. Okay. And the fact that I would put GraphQL in the box of mature technologies, okay, and it's great for the thing he's great at, and not great at the thing he's not great at, okay, and you should know, and just not to, is not the only, tool you have in your toolbox. So you need to know when to use it and when not to use it.
And I mean, it's also not the first tool, right, that built in this contest. We remember that eBay built something, Netflix with Falcor.
But then there is gRPC. Like you could do similar things to some extent with gRPC, okay, and solve things in different ways. Like this is kind of problems is always going to exist. And
so it's the orchestration problem that came when we started building the best friend forever.
Yes, best friend. Let's start with the best friend forever, Luca.
You don't know where that thing comes from. It was a TV show where there was Paris Hilton, and I don't remember, I think Osborne or somebody, and there was like a Paris BFF, best friend forever.
And Luca. Okay, so let's talk about the backend for front end. Okay. Look, the key things here is very simple, to be honest. Why you need a backend for front end? Because your enterprise typically system has some internal APIs that are typically ugly, very bad. Okay.
So you have some legacy API and you want to build a modern front end and you need to write some sort of like strangler to this.
Exactly. Okay. To these old systems. Okay.
Same.
This is the typical, because you can't, for various reasons, access from the front end the backend APIs. Okay. So you do this backend for front end component. Why this is actually needed in a lot of cases? Because the backend for front end is can act as a security boundary between the two things, so that it provides an additional layer of safety, but also it's sometimes you cannot access those internal APIs from the outside. The backend for frontend is built to be accessed from the public internet. So there is also that needs to be taken into consideration when building one. Okay. Now, when GraphQL was born, it was solving two problems. Okay. Underfetching and overfetching. Okay. What are those? Okay. So when you're building a front end app, okay, you want to be able to get only the data that you need to minimize bandwidth and computation. Okay. Mm-hmm. So if your APIs is you are underfetching, it means that you need to issue more API calls. Each API call, if you are on a public internet, might be 200 millisecond round trip. Okay.
Was like the old good href APIs, right?
Exactly.
Where you just get links and get more data.
You need to get more data. Okay. You do fetch and keep until let's say that you have an endpoint that is a page. Okay. Mm-hmm. And then you have page details that you need to call to get the content of that page. So in order to render that page, you need to issue one fetch to get the first one, and then you need to get another call to get the second part. Now, these back and forth, and you can even do it worse, okay, and have and build those kind of APIs in a way that the ID of the details page of the details of the page is hidden inside the request of the first fetch. So you cannot even parallelize them. You need to actually wait for the first, have a waterfall effect from the first, wait the result of the first query, go to the second query, to put into the second query. And this is a very trivial example, but you can see this everywhere. Okay.
Yeah.
This is essentially you're doing 2 calls when you could do 1. Okay. And this is one problem. Okay. Now the second problem it solves is overfetching. Okay. So imagine that I need to get all the data. Okay. Now you're returning a JSON blob that is 1 megabyte because it has all the fields. Okay. You want to be able from public internet to only transfer the data that you need to save bandwidth because you might be on mobile and that transfer time of a lot of data can be problematic, especially with big lists. Let's say you're listing 20 elements. Okay.
Yeah.
Those things adds up in both in terms of transfer bytes, but also in terms of time that it takes to parse and render and filter and do all those things. So I want to remove the properties that I don't need. Okay. And these are the 2 bits. It also solves a third problem. Okay. Which I think is the most important one. So these first 2 are technical. Okay. This is a good things to have in a public API. Okay. The third one is organizational. And this is where GraphQL has shined. And I think is a crown jewel, is why it became popular. Okay. It allows it removes friction between teams. So if you have a front-end team, a mobile team, a TV team, okay, because we work with a few companies that have TV teams. Okay, this is fun. Okay, it's a fun topic. Hi everyone. Okay, the TV teams all call the same GraphQL endpoint, but they need different data. Okay, to render their pages because they need different things displayed. So because of that, companies can have a single GraphQL endpoint that can serve all of them. Okay. Because each one of them can decide, I want this field. I want the data formatted in this way. I can do this other thing. I can do that. Okay. They can manipulate the query, okay, to adapt it to their needs, especially with GraphQL fragments and a lot of these things. You can do phenomenal things with GraphQL. Okay, they can even combine multiple queries into one single back and forth. Okay, I can ask, I want two queries, run them at the same time in parallel for me. Okay, and you get the results. Perfect. Okay, now all of this is great. Okay.
It reminds me, sorry, of OData though.
It absolutely, like, man, it's not born like GraphQL is only the one of the things in the history. Okay, then the next one, then we had others that came after it. Okay, and there were things that came before it. Okay, so it's great. Okay, it's great. It has its quirk, it's good things, bad things. Okay, it reminds
Probably
you of
better marketing than OData.
well,
That's the truth, right? I mean,
yes.
It's just it's
Yes.
just
So
but so we were talking about kind of like but let's compare it against a BFF, right?
yes.
So a traditional REST BFF. So you say basically it gives some out of the box technical functionalities, but filtering I can implement it in Fastify, no problem. I can implement everything, right? Because I still need to write my resolver behind the scene to tell him what the filter is, right? However, what you say is that from front-facing standpoint is the organizational advantage that this brings to the organization. So the sense of like having, it's probably a stretch, but to say I have a data platform and I have these outcome consumers that they kind of like consume this data source, this service as if it was a database and they were writing SQL. But so that's basically is what you think is the winning point for GraphQL in enterprise.
Yes.
but like it cannot only be this, because to be honest, it could be that anybody can write some sort of like generic interface or a new plugin for Fastify that does the same thing. Where is the, like when we look into other stuff, like for example, caching, right?
Actually, no. Caching, actually, no, Luca. So that is one of the key reason why you're missing one point in your
Mm,
reasoning. Okay, it's absolutely easy to add a set of endpoints. Okay, now the
mm,
problem is that then every time you need to consume the complex APIs that you have behind the
mm,
scene. Okay, let's say that you have, I don't know, 20 to 30 microservices behind and you need to expose them in a way that makes sense to the end user. Okay. Each time you want to do that, they will create a new BFF. Okay.
mm,
So you will end up having a BFF for the front end team. You end up having a BFF for the mobile iOS team. And you will up having a BFF for the mobile Android team because it's a different team. Okay. And they want slightly different APIs. Okay. And then you're going to have another one for the for whatever you are using. Okay. All of these add massive complexity. So there is a clear advantage in having a single data level endpoint for everything to go through. Okay. Um, so that is which it that allows each one of those consumers to adapt their queries to their use case. So that's the key point. Okay, they can adapt the queries to the use case. Okay,
mm.
so
Okay.
but there is one more reason. Okay, and this was one of the that is also true for public consumption. So, for example, imagine that you want to offer a public API. Okay,
Mm.
if you want to offer a public API, you might not know what how the customers want their data. By providing GraphQL, they can decide for their own. Okay.
I know, but I'm enforcing a protocol that is not really widely standardized.
Sorry.
The GraphQL querying
Yes.
is not widely standardized in enterprise. If I need to integrate with the SAP API, you will not find the GraphQL endpoint. You will find the REST endpoint.
I know. I'm just saying.
Open
Well,
banking.
we have seen a few cases where that is the case, Luca. So it's not
But it's the
uncommon.
case for the UI. If you're
No,
kind of
no, even for backend to backend integration, not just the UI.
for backend to backend integration,
Yes, not
that's
just UI.
that's rare to find.
It exists. Okay. Then there is a lot of usage of federation too. Okay, and composition. So
Mm.
there is this. The first pioneer was Apollo that created Apollo Federation, which is and a variation of this is in the process of being standardized as the composite schema by the composite schema working group at the GraphQL Foundation. Hi, folks. And they basically what this does is it takes several subgraph schemas and merge them into one, so that the same thing that you can do upfront with the consumers you can do on the backend side. Okay, and have multiple microservices offering the GraphQL schema to be composed by a single component.
By
It
a single,
works
okay.
by a single server. These
Okay.
were there are a few you can companies buy this from a few different vendors. Okay, there are a few implementations of this. Some of them open source, some of them are paid products. There is a thriving ecosystem on the topic. Okay,
And why do
uh,
you think it's so compelling to organization, the composition, or yeah, the federation?
because of the organizational complexity
So you basically
of
have team A, team B that they develop two separate schemas that they are queryable from a single centralized schema.
Exactly.
Query, sorry.
Yeah, exactly.
Okay. Yeah, I can see that. But then, yeah, I can see that. I can see that.
Like it reduces overall the engineering overhead
But
of and this kind of thing was done by a lot of other companies in a lot of different, like it's not common to GraphQL, the same of GraphQL. There's a lot of other organizations that have done similar things. Okay. I think Netflix has its own implementation of this thing. Okay.
well, they come from Falcor.
So they implemented this
No.
themselves. Okay, they have
No, then they migrate to GraphQL because Falcor was like a glorified.
Yeah, but again, they use this pattern. We have all these microservices they integrate into one thing. Okay, it's fine.
Yeah.
So it's it is what it is.
But what about AI? Because now everyone, I remember Augusto Marietti from Kong saying there is no AI without API, but I don't think AI is ready to talk GraphQL.
That is, well, okay. Let me say a few points.
Or
okay?
agents, right? You know what I mean.
So the first thing, agents can write GraphQL queries as any other sort of code. Okay, they can write SQL, they can write GraphQL, they can write whatever. They've read it all. Okay, they've read all of what is on GitHub, so they know exactly how to write proper GraphQL. Okay.
Yeah.
One of the problem is MCP, Model Context Protocol, that was built not around GraphQL, even though it could have been. Okay, and which is very complex. It's a complex protocol. Okay, and it's not GraphQL. Okay, so and that's the protocol being used for the integration on the chat assistants that you have seen. Okay, and it's pretty cool protocol for those integration, to be honest. So I'm huge +1 on that. Okay, but I have no, but that's not GraphQL. Okay, but it can, of course, like it's GraphQL can be run super easily on top of any HTTP connection. So if you can curl, you can do GraphQL. Okay, and it has a schema, so it's in fact that AI have absolutely no problem in reading and writing and producing it. It's just not the language used for the client integrations.
Yeah. I think there is. I mean, in my opinion, being working in enterprise, I always saw the value of GraphQL, and there are different ways that you can actually even expose it. I think GraphQL is not probably ready to be a public protocol. In my opinion, lacks a lot of the security and compliancy and governance that REST has. But it's a great internal protocol, right? Like in Talos, for example, we wrote this GraphQL kind of like layer that was then mapped into static REST APIs on the gateway. And that was massive, right? Because you could completely decouple the world of enterprise integration with the world of like internal development, right? And the fact that there's a schema, I can verify the schema, a JSON schema or an OpenAPI schema against a GraphQL schema, right? Because they're schemas.
They are schemas. They are indeed big schemas, Luca.
So,
and but to be honest, the schemas are the most nice thing that you can get.
yeah, because it makes contract-based communication,
It's
right?
contract-based communications. Okay, once you use schemas, okay, if you use, for example, OpenAPI, you have some of the same benefits. Okay, but also not all. Okay, it's but it's REST and easier to some extent to integrate and communicate with than GraphQL, where you need more or less specialized clients.
Yeah.
So you have this kind of dual-faced logic. Okay, and in GraphQL you have to write those queries, and with REST, with OpenAPI, you don't. Okay, like that's there is a level of computational complexity around deploying GraphQL that makes it a more heavyweight
Yeah.
and a little bit harder to deploy and manage and observe than REST solutions. But as always, this is a trade-off you need to make, okay, to have the benefits we talked about. So if you have the benefit, if you want the benefits, there's a price, okay, to be paid for
Always.
those. There's a price
Always.
to be paid for those things,
Always.
okay. And this is where there was a thing a few years back where GraphQL everywhere. This is GraphQL. GraphQL. REST is dead. GraphQL. 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 GraphQL everywhere. And it was shoehorned in a few very like odd things. Okay, like why? They make no sense whatsoever. Okay.
I think it's also a result of this transitional phase. I remember when we went from REST to obsession for REST. Then we went to hypermedia, hyperlink APIs. Then we went into JSON patch. Then and slowly came into the realization, and eBay was the first one with the JQ. Don't remember. Yeah, I think it was JQ. They're kind of like query language for the web, and then Falcor, and finally I think GraphQL formalized. But I think it's a kind of like reflection of where the developer community, but also the enterprise need went. Like they wanted to reduce cost of implementation and risk of implementation. But to me, it's just like, for example, let's like one of the things is that GraphQL creates a very strong abstraction between the front end and the back end. It's some sort of like mediator between what the front end wants and what the back end can give.
Yeah.
Right. The microservices world didn't make anything good to this universe, but just creating even more friction and more fragmentation, in my personal opinion, and slow down the time to market for absolutely no reason. Once again, my opinion, I take responsibility. We are not actually selling the Tao of microservices here. Actually, probably the opposite. But where I see the great kind of like gap is that, for example, GraphQL, and we know one of our customer runs massively on GraphQL, but still, like the monitoring and debugging, the experience is like
look, it's a new protocol sitting on top. You need to add. You need to know what's happening. Okay. Especially on Node.js, adding distributed tracing to it is insanely expensive because of how the GraphQL resolvers are set up, and the fact that you need to wrap a lot of promises and with more promises, essentially. So if you write your system not perfectly, you're going to get an insane amount of promises being allocated, and this is going to significantly hit your performance. So this is a problem of GraphQL. Okay. Solving this would require essentially, I think, a little bit of how the of how the GraphQL library is built and implemented. It's possible. It's something that we are thinking is in the design phase, I would say, at the foundation. So yeah, pretty good.
Yeah, but I think honestly, like what the protocol lacked in the past was really to have like transparency as a primitive. Like, why is not built around OpenTelemetry?
It is built around OpenTelemetry, Luca.
No, I know, but what I mean is that why isn't it the GraphQL ecosystem, right? Since its beginning, having, for example, also the tool chain to have visibility over all the queries and so on.
The problem exactly. So the fundamental point here is that you needed to have a low-level mechanism Now, the answer to that point, Luca, is that low-level mechanism did not exist in Node.js to provide. Okay, so
yeah, but the GraphQL was the first implementation was not in Node. It was a protocol that
yeah,
was
but the problems are that there is nothing in GraphQL like right now. Sorry, let me rephrase this. OpenTelemetry, okay, as is orthogonal to GraphQL, okay,
100%.
it is being standardized. So there is a standardization side right now of OpenTelemetry metadata for GraphQL. So that is finally happening. Should have happened sooner. Yeah, but it's happening. It's possible. It's absolutely orthogonal to the topic. Okay, it's not related. The cost of running OpenTelemetry with Node.js, okay, is entirely on how observability or how distributed tracing can be implemented in Node, and how that could only have been implemented in Node in a certain way for a long time. Okay, now there are faster and better mechanisms that can be implemented. Is part of the reason why OpenTelemetry integration is actually significantly faster or in our Kafka library, because we use the new stuff. Okay. And it's the new stuff. It means it's a thing called diagnostic channels. So is to clarify the problem is so in with old school way you add these agents that you added to is everything is an agent. Okay, the agents that you installed in your system that go and monkey patch every module. Okay,
Yeah.
so everything of your resolver needed to be monkey patched, each one of them, to know when it started, when it ended. Okay, now with diagnostic channel, okay, what you can do is to have the machinery emit those data, those things, okay, without having to do the monkey patching. Now, because it's promise based, everything of this monkey patching adds one more promise. Okay.
Yeah.
The problem is if you have a graph this big that doesn't fit the screen, okay, and each one of them allocates a promise, and you have 100 promise here, with adding OpenTelemetry, suddenly you have 200 promises.
Yeah.
And you see where this goes. Okay.
Yeah. But
In the point. So. And we had Ryan talk about a lot of this, and you should check that episode. It's one of my favorite episodes of this show.
Yeah, we actually quoted already several times in the past few weeks. But another fellow Canadian. But what about the whole kind of like caching and so on? How do I do it in caching?
Caching?
Well, something that probably is older than you and I.
Caching in that? So the GraphQL, there is no caching in GraphQL. Okay?
So, but how do I actually overcome that problem?
Okay,
Because
there
it's
are a few bits. There is no caching in GraphQL. However, a lot of commercial products solve this in different ways. Okay, typically
let's do some promotion.
directives.
And they sponsor.
We don't have sponsor for this, so
we are not gonna tell it to anybody.
I am not gonna tell it what the various product does. Okay,
Apollo,
including my solution, but
talk?
I'm not going to mention it. Okay, I have a solution for this. I'm not going to mention.
Free
it's possible.
Or commercial?
Free open source.
Then unfortunately you need to say, or else commercial. I could have asked you for the sponsorship fee. Apollo, do you want us to talk about your solution? Feel free to reach out. We can send you an invoice. Well, so give me a list. I'm gonna reach out to them. Do you want us to mention your products?
They're probably watching some of them the show, so next time they can.
I always hope that one day Guillermo is gonna watch our show and comment in our
and show
say,
up.
I love
and
this
show up and show up. Come on.
We should invite him. Now, we basically is basically now family and friends. We should just like invite him once and say, look, Guillermo, we mention you every single time. Just come over and we just drink a coffee. And
cool.
Maybe we can take out the Italian that is inside of it.
So,
but no, Luca, caching. Tell me about caching. Like we have 3 minutes. I need to know about caching.
The caching, caching is actually very It's
No, Theo, the
literally
stuff that you build for free. I want to know what I can get for free.
Basically what I built is
I love
called
freebies.
Mercurius Cache. Is built on top Fastify and Mercurius, which is the GraphQL adapter for Fastify. Everything and what it does, okay, it's technically a very simple implementation in the sense that for certain resolvers in GraphQL, it can first deduplicate the request based on the arguments.
Mhm.
So it can say, okay, these things is being requested by 5 different users, okay, and you need to we can just get it once, okay, and you can also so it deduplicates first, and then it can also cache it for a certain amount of time on top of Redis. So that's it.
Okay.
And it works very well, to be honest. Like the performance is phenomenal. Okay. And it's built on my low level caching module. So you can just use the caching module for this if you want, if you are interested. But the concept is the same, and it's and every single other product that does GraphQL caching work in the same logic. You provide some configuration telling what to cache, where to cache, how to cache, and if there are other things that you need to take into account, like HTTP request headers, users, blah blah blah, something like that, profiles. So you can say, you can do those kind of metadata thingy. And then it gets cached for a while, and then you can get stale responses like HTTP. Okay. To be honest, caching is a solved problem, not in the standard, but in the associated products around GraphQL. So it's not really a problem anymore. But to be honest, a lot of organizations have no caching at all. Okay. I've seen a lot of companies really not shipping caching at all with GraphQL, mostly because they fear about stale data. So they don't want to have stale data, or they have huge user personalization strategies. So they just don't. So to be honest, it's a solved problem, but also probably not that big of a problem from what I've seen.
No, good to know that you build it for free, so everyone who wants to use it can use it for free without paying any ransom. Theo, we are at our 30 minutes mark.
Yay! Do you want to know any, folks? Do you want to have any specific juicy details on GraphQL? Comment out. Call me. Call Luca.
No.
Call Luca.
No.
Okay.
We can put actually on the video your phone number so people can contact you.
Exactly.
No, jokes aside, I think it was good to chat a little bit with GraphQL. There's always this kind of topic that goes in and out. It's like the John Richmond jeans. They go in fashion, then you need to freeze them for 5-6 years, then they come back. It's kind of like it's like the fashion life cycle. Anyhow, looking forward to next week's chat, Theo. Till then, ciao. And ciao everyone. Bye.
Bye.